Double angle and half angle identities. For this section, we'll need the unit circle, and we'll also need the double angle and half angle identities. So if you could have those on a piece of paper in front of you, they are on Point Learning, and it would be helpful to have those. We'll start with the double angle identities, and you can see them here. The cosine has 3 different formulas, and it really won't matter which one we use. You can just choose whichever one you want. The tangent has 2 different formulas. So the problem you'll have in your homework will say, find sine 2x, cosine 2x, and tangent 2x from the given information. Then you're given that the sine of x equals -3/5, and that x is in quadrant 3. They tell you the quadrant so that you'll know if your answers are supposed to be positive or negative. In quadrant 3, both the sine and the cosine are negative. Cosine is negative, and the tangent is positive. So, in order to use the formulas, we need just regular sine and regular cosine, not with the 2's. We already have sine. It's -3/5. So to find cosine, we can use the identity sine squared plus cosine squared equals 1. We have sine, it's -3/5, so -3/5 squared plus cosine squared equals 1. 3/5 squared would be 9/25 plus cosine squared. And I know I'm going to have to subtract fractions, so let's go ahead and get our common denominator. 1 is 25/25. Subtract 9/25. 25 minus 9 is 16. And then we need to square root both sides. Now remember, when you square root both sides of an equation, you have plus or minus in front of the answer. But we know that we only need the minus because the cosine is negative in quadrant 3. So when we square root both sides, we're going to use cosine is -4/5, square root 16, square root 25. Okay, so I've got sine is -3/5, I've got cosine is -4/5, and now I have what I need to use the double angle identities. The cosine, let's start with sine. The sine of 2x from the formulas on the previous screen is the formula 2 sine x cosine x. So that would be 2 times -3/5 times -4/5, which is 24/25. Cosine 2x has 3 different formulas we can choose from. It really doesn't matter. I'm going to use the one that says cosine squared minus sine squared. So that's going to be -4/5 squared minus -3/5 squared, which is 16/25 minus 9/25, 7/25. And then the easiest formula to use for tangent, if you already have sine and cosine, is the tangent 2x is sine 2x over cosine 2x. So it's going to be 24/25 divided by 7/25. We're dividing fractions, so flip the second one and multiply. 24/25 times 25/7. So it's 24/7. Be sure to check your notes for homework hints. I've given you some about the double angles. Now we're going to look at half angle identities. There's a little plus minus in front of every square root for these formulas. Whether the plus or the minus is used in front of the square root depends upon which quadrant the original angle is in. So for example, if I want to find the tangent of 75 degrees, 75 degrees is in quadrant 1. And in quadrant 1, the tangent is positive, so I know I need the plus. Now the formula says tangent of theta over 2. We need something over 2 to equal 75. Well, 150 over 2 equals 75. So we'll write the tangent of 150 over 2. We just converted our 75. We don't want that to change, but we wrote it in a different way so it would fit the formula. 75 is the same thing as 150 over 2. So basically, whatever your original angle is, just double it. And then the 150 is the theta in the formula. So in the formula, everywhere I see a theta, I'll put a 150. For the tangent, the formula says 1 minus cosine theta. So 1 minus cosine 150 over 1 plus cosine theta. Now go to your circle and look up the value for the cosine of 150. And the cosine of 150 is negative square root of 3 over 2. So I've got a positive square root of 1 minus a minus would be plus square root of 3 over 2 over 1 plus a negative square root of 3 over 2. And you can just leave it there. Let's try another one. The sine of 15 degrees. 15 degrees is in quadrant 1. And in quadrant 1, the sine is positive. Now, we double 15, and that's 30. So we're trying to find the sine of 30 over 2. And 30 becomes the theta in the formula. The formula for sine, and I'm using the positive square root because the sine is positive in quadrant 1, is 1 minus cosine theta. So 1 minus cosine 30 over 2. Then I go to the circle, look up the cosine of 30. It is square root of 3 over 2 over 2. All of that underneath the square root could be simplified farther. I'm just not going to make you do that though. Next is the cosine of pi over 12. So what we might want to do is convert to degrees. So pi over 12 is the same thing if we multiply by 180 over pi, converting radians to degrees, we get 15 degrees. And again, just like the previous problem, that's quadrant 1, and the cosine in quadrant 1 is positive. Now if I double 15 degrees, I've got 30. So I'm finding the sine of 30 over 2. Not the sine, the cosine, sorry. 30 is the theta. The formula for cosine is the square root of 1 plus cosine theta over 2. And the cosine of 30 is square root of 3 over 2 over 2. Let's do one more. The cosine of 7 pi over 8. So let's convert 7 pi over 8 to degrees. 7 pi over 8 times 180 over pi. The pi's would cancel. You end up with 157.5 degrees. That's quadrant 2. And in quadrant 2, the cosine is negative, so we'll need a negative in front of our square root. Now we double 157.5, and that's 315 degrees. So we're finding the cosine of 315 over 2. 315 is the theta. I know I need the negative because I'm in quadrant 2. 1 plus cosine of 315 all over 2. And the cosine of 315 is square root of 2 over 2. So 1 plus square root of 2 over 2 all over 2.